Here's word problem number 3 in chapter 1. The term 1/2 rho v squared occurs in Bernoulli's equation in chapter 15, with rho being the density of a fluid and v its speed. The dimensions of this term are, well, to figure out the dimensions of this term, we have to figure out the dimensions of the components. So rho is density, that's mass per volume. And if I were thinking of this in terms of dimensions, we could represent mass by m, and volume is 3 spatial dimensions, so that would be length to the cube. So that would be x, y, and z, so to speak. Velocity is meters per second, so that's going to be length per time in terms of those units. So if we're looking at 1/2 rho velocity squared, that's going to have units corresponding to, for density, mass per length cubed, and then for velocity, length per time, and those units squared. So this is going to be mass times length squared over length cubed times time squared. In terms of the length squared and the length cubed, we'll be left with just length there. And then this would be mass over length times time squared. Or I could write it as mass length to the -1 time to the -2. This is a dimensional analysis of this term, and it might just help you determine the quality of terms within an equation. So that's our answer. Mass, length -1, time -2.